Good afternoon, everyone. Welcome to today's webinar. My name is Rez Mani, and the title of today's webinar is the Lighting Passport Instrument and its Measurement Capabilities. So I've given this webinar a number of times, and every time I try to include new things, the progress, the changes in software and the hardware, and something new that basically if someone has attended this webinar before would not get bored to look at it again or to listen to it again. So this webinar is being recorded and the recording would be sent to you within a few days. Also like to talk about the two previous webinars that I gave. One was on January 12th and one was on April 6th. And we're glad to say that we have a YouTube channel right now. And I'll send you the link to this YouTube channel, and you can see these two webinars are there already, the YouTube format. So if you haven't watched it, you can go ahead and watch it later after this webinar is done. And the special thing about these two webinars were that in the January 12th webinar, I did live measurements from 4 different lamps, fluorescent, incandescent, LED 3000K and LED 5000K, and I recorded the data on the cloud. So this gave good information about the functionality of the cloud and how to do the measurements. And then on the April 6th webinar, I basically analyzed the results from the cloud. So I compared, like you can see, for example, here in this little clip, you have 4 different spectra. I compared their spectra and all the other characteristics. So if you haven't watched these webinars and you would like to look at them, I'll send you the link to the YouTube channel, and you can go ahead and watch it. So what is different about this webinar? We are focusing mostly on the human-centric aspect. We sent a follow-up note to you guys about this. Initially, we were just doing a normal webinar, and then because there was some developments and we developed the app that could do the human-centric measurements, we decided that we're going to talk about this and introduce you this new version of SGM Plus. So I'll be focusing a lot on that today. My email is also here, so if you have any questions, you can email me. We also have a Q&A session at the end. So what we're going to talk about today, first we start with the TM30 standard. So I'm sure you know about the TM30 standard. We would look at how to generate the report using the lighting passport data on the cloud, and also the new additions to the SGM Plus, which is version 1.8.0. We have changed some of the graphics in this new version. So I'll show you what we have removed and what we have added. Then we would go into the human-centric lighting, which is quite a hot topic these days. It's important for human health, and we would discuss different benefits of circadian light and how important it is for human health. And then we would talk about the CIE S026 international metric-based standard that quantifies some of these human-centric parameters. And we've also had additions to SGM Plus version 1.8.0. We'll go through those as well. Then there is also the circadian stimulus scale by the Lighting Research Center, and now they moved to Mount Sinai. So they also have the circadian light version 2. There was a version 1 before. Now they recently modified their model. And we also have some changes in the app, SGM Plus 1.8.0. And finally, I would talk about how to verify these human-centric measurements produced by the lighting passport by online spectral calculators. So you would find confidence in the measurements and the results that you're getting. You could verify that they're actually correct. And if time permits, at the end, I'll talk a little bit about Flickr. So throughout the webinar, I'll talk a lot about the app, and I talk about the theory, but I also talk about the usage of Lighting Passport and the cloud and the features of the app. So this will be useful for those who want to use it. So let me start by TM30, IES TM30-20. So we know that before we had the CRI index from the CIE, and that had the fidelity index RA, and that was not basically a complete standard. For the reason that CRI is just an average value which measures only fidelity, and two light sources which could have the same CRI could have different light rendering. And the picture below shows this. This is the original picture on the left. And then you can see in the middle, you have another picture with RA of 70, and another one on the right that also has RA of 70. But these two are quite different from each other. One is desaturated and one is saturated colors. So according to CIE's standard, they both should be the same. So the RA value is the same for both of these. So it's something similar, like if I want to come to someone's house and I say, well, where is your house? And the person says, you're 50 miles away from my house. That information is not complete. But 50 miles, should I move north? Should I move south? Should I move east? Should I move west? In which direction? So the CIE scale does not give the complete information. And for this reason, the Illumination Engineering Society devised the TM30, which was originally in 2015, then 18, and now it's 20. So it uses more colors, 99 colors instead of 7 or instead of 8, and also has 2 different indices. So I'll talk a little bit about those as well. So as I said, there are 99 test color samples which reflect a better example of the complexity of today's world. And it uses 2 indices, RF and RG. Please put all your microphones on mute, if I may request, please. So yeah. So instead of RF and instead of just one value RA, it has RF and RG. RF is similar to RA of CIE. It's a fidelity index and it's a scale of 1 to 100. And RG represents the gamut index, which deals with chroma and hue shifts. And its value could change between 60 to 140. So if a value of RG is more than 100, it means saturated colors. And if it is under 100, it means desaturated colors. So it gives some more complete information. TM30 also has color vector graphics, which gives a very good indication of what the color rendering is. Just by looking at the graphics, you can get a really good idea of what's going on. So TM30 has this standard report, and the Illumination Engineering Society has made the spectral calculator where you can print this report. So you can see when you look at this report, here you have like all these 4 parameters, RF, RG, then you have RFH1, RCSH1, because there are 16 slices in here. So you can say in each slice, the average value, what it is. So this is only for number 1, RCS colors, chroma shift in H1, cube in H1, and fidelity in H1. And you can see desaturation here, for example, when this is inside the circle means desaturation, and you have inward arrows, and when it's outside, it is saturated. So it basically gives local chroma shift for each of the 16 bins and local hue shift for each 16 and fidelity for all 16 bins. You can see the spectrum here and also the reference to spectrum that has the same color temperature. And at the bottom, you will see the 99 color fidelity. So all of these are the fidelities of each color. So this report can be generated by, also, I forgot to mention, you also have CCT information, DUV, and these are the Annex E information. If you want to know more about these, please watch the previous webinar that I will send you on that YouTube link. What I would like to do right now as the first step is to show how we can generate the report using the calculator. Okay, so before I get that, I want to mention that you need to send the data. Once you do the measurement, you have to send the data to the cloud. So this is the picture of the SGM Plus, and at the top left corner, you have this menu. So you need to go there and go to cloud management and put the synchronize to auto. So that means that the data that is being produced is synchronized to the cloud. The other option is manual, so make sure that this synchronize option is put to auto. So you can see the other option is manual, so we want to put it in auto. And once you do the measurement, you need, at the very beginning, you see there's this warning sign, yellow warning signs appear there. This means that the data is still not on the cloud. So if everything works well, and it will, once after maybe 30 seconds or maybe even less, this warning sign disappears, and then you can see your data on the cloud. So if you keep seeing this warning sign, it means the data is still not on the cloud. You can try clicking on this cloud, but ideally within a few seconds, this should go on the cloud. Okay, so what I'd like to do is I like to start the calculator. So I would start the calculator here. This is the TM30 calculator. And then I would go to the cloud and download one set of data. So this is the cloud, spectrumgenius.com. You can see my picture is there, so I've logged in. If you don't have an account, you need to go and register and some basic information, give some basic information, name and email. And also once you download the software, the app, it will ask you for the same login and password. So I will go ahead, and this is one of the measurements, the 3000K. So I would click on that, and then I would go ahead and say download. Okay, so once I do the download, it should appear here. A second. It's a little bit complicated with different windows open here. So let me do that again. So I go ahead and do the download. Yes. Down. Yes. So this is the 3000K. So I would go ahead and copy the irradiance values. These are the irradiance values. Control C, and then I would go to the TM30 calculator, and I would just say create table. Create table. I would copy this data in here, and then I would just say calculate. So once I do the calculate, this same report belonging to that data appears. You can see this is a 3000K spectrum, 99 color, and it's all given in here. And at this point, you can go TM30 full report, IES TM30 full report, and basically you can you can create a PDF out of this. So you can do a high resolution PDF and you'll have the report in the PDF format. So this way you can print your report. You can see, open file. This is the PDF report. Okay, so that part is done. And now let's talk about the new version, which is version 1.8.0. And so far, we just have the beta version. And I'll send you a link at the end of the webinar so you can basically play with the beta version. And within a week or so, we will release it on Google Play. So far, it is only for Android, and but we will release it for the iOS as well. So what we have changed in this is that we have removed these two graphics. So we thought that we want to move closer. The logic behind this was we want to move closer to the TM30 report, and these were not in the TM30 report. So we already removed this. And then what we have done is there was a change. If you look at the previous version, you see that the graphics has this checkered board. So we wanted to make sure that it is close to the TM30 report. So we made it a pie chart, as you can see in the right figure. And you also have the select type here at the top left. So if you click on it, then you'll see some additional TM30 charts. So these are the new ones. They're all from the screenshots from the new app. So you have basically the 16 color fidelity from each hue bin, local chroma shift, local hue shift, and these are the 99 values of the fidelity indices. So all of these are there. These are all brand new in the new version of SGM Plus. Okay, so talking about that is done, and now we would move on to human-centric lighting, which is the hot topic these days. I was myself at the light fair in Las Vegas, and I saw there's a lot of activity in this area. A lot of companies are working to make tunable lights for residences and offices. And the idea is that human beings were brought up under the natural sunlight, and you can see that the sunlight throughout the different parts of the day changes its color temperature, its intensity, and during the early morning and late evening it is warm colors, lower color temperature, and at noon there is during the day there are higher color temperatures, cooler color temperatures. So this is the way human beings were brought up over thousands of years. We evolved under this kind of lighting. And over the course of the last few hundred years, where technology developed the electric lighting, we are stuck with one type of light only. And this is not healthy for the human body. So this variation will set the clock. Yes, there's a question here about essence. I'll talk about that at the end. I will definitely answer your question about the essence. So let me finish this on the human-centric lighting. So we have this variation, and we need to be able to produce or reproduce this variation in our residential settings as well. So this will set our circadian rhythms, and I'll talk how that happens with these new photoreceptors called IPRGCs. The way natural light from the sun operates is that during morning and evening, the light has relatively warm color, but spectra is not exactly the same. At noon, the color temperature is at around 5,000 K from the sun and 14,000 from the sky. And at night, its light level is pretty low, only moonlight and starlight. So as I said, the humans developed 24-hour body clock and the variation of the color temperature. And this would cause a state of being alert during the day and cause sleepiness at night. So at the time, in the old times, 90% of the time were spent outside. We evolved under these conditions to be outside 90% of the time. Due to advances of technology, now we spend only 10% outside, and the intensity and color temperature of the lights inside our houses or offices remains the same. So it doesn't change. And this is not good for human health and the way body has adapted to natural light variation. So there is a biological clock in each human, and it is set by these new photoreceptors that were discovered in 2002 called IPRGC, intrinsically photosensitive retinal ganglion cells. And basically they would receive the light, which doesn't have a visual function. It's a non-visual function. So it will send a signal to what they call the suprachiasmatic nucleus, LCN, inside the brain, and that will set our clocks, body clocks. So the IPRGCs are especially responsive to blue light, and this circadian response of the body due to these IPRGC photodetectors are even observed in blind people who don't have any visual capabilities. So here's a picture of these photoreceptors. We are already familiar with rods and cones. The cones are responsible to detect colors. Rods are for black and white, low lighting conditions. And these IPRGCs are at the back of the retina, and they are responsible for the non-visual aspect and the circadian rhythm in the body. So there are 5 types of photoreceptors. We have the S-conopic, M-conopic, L-conopic, and this is short wavelength, medium wavelength, and long wavelength. And then you also have the rhodopic, which is for dark lights, and you also have the IPRGC, as I said, it's for the circadian rhythm. So IPRGCs are photoreceptors, and inside them there is this photopigment called melanopsin, and they have their own characteristics absorption. So in the lighting passport, in the previous version, we provide these melanopic locks. So basically how the spectrum is modified by each of the spectral sensitivities of these photoreceptors. But these were old calculations by a standard prior to S026. And now the values have changed because we are using S026. So I'll talk about that. You can see the action spectra for the 5 photoreceptors. This is S-conopic, the melanopic, which is centered around 490. Then you have rhodopic near 500, and then M-conopic around 530, and L-conopic around 580. So basically you would weigh the spectral power distribution with these action spectra, and that will give you the respective irradiance. So if you weigh it with the melanopic action spectrum, it will be melanopic irradiance. So I'll talk more about the standard a little bit later. So what is the effect of circadian light? The circadian light is basically sets the circadian rhythms. It causes secretion of melatonin at night, increases heart rate. Sorry, this is not right. This is heart rate, improves alertness, alleviates seasonal and non-seasonal depression. It influences thermoregulation. It affects the electrocardiogram spectrum, and it affects the brain activity. So it is important for human health to have circadian light. So in order to quantify the amount of circadian light, which is in a residential area or in an office or anywhere else, the CIE had to come up with certain standard, and this was done in 2018, CIE S026 Standard. So I'm going to go ahead and talk about these, and then I would like to basically show you that we have incorporated a few of these parameters in the new Lighting Passport app. So, but let's first understand what are these parameters. So these are all codes from the S026. Lighting standards, regulations, and practice often focus only on visual and energy efficiency aspects of light, do not address non-image forming responses to light. And this can result in lighting conditions that compromise human well-being, health, and functioning. Light is not only a way for vision, it's not only essential for vision, but also achieves some other important health effects, biological effects relative to health, performance, and well-being that are not dependent on visual images. And in vision sciences, photobiology, it is very useful to define standard physical quantities which are based on action spectra that describe an average sensitivity to light. So here is the CIE S026 CIE system for metrology of optical radiation for IPRGC influenced responses to light. And we are going to talk a little bit more. We already talked about the 5 photoreceptors, S-cone, M-cone, L-cone, rhodopic, IPRGC. This international standard, it defines spectral sensitivity functions, which I already showed you in a previous slide, quantities and metrics to describe the ability of the optical radiation to excite each of the 5 photoreceptors to produce basically non-visual effects of light in humans that can also be seen in blind people. Yeah, and actually, it's also a fact that it's not only the IPRGCs that contribute to these non-visual effects, some of the other photoreceptors also contribute to it. So in other words, new international standard basically provides the SI compliant way of quantifying the influence of light on the IPRGC melanopsin that mediate non-visual effects of light. So it talks about how these quantities affect the the basically production of melanopsin, or production of how they affect the circadian function of the body. That's why these parameters have been defined. So let's try to understand some of these parameters. So the first parameters that I would like to talk about is the melanopic efficacy of luminous radiation, or MELR. So at this graph over here, you can see this is the melanopic action spectrum, which is centered around 490, and this is the photopic function, which is at 555. So here you're dividing the melanopic irradiance. So C lambda is the action spectrum, S lambda is the spectrum, divided by the photopic function. And this Km is luminous efficacy of radiation for photopic vision, which is known to be 683 lumen per watt. Okay, so if this numerator is in watts per meter square, it's irradiance, and if this one is watts per meter square, and this is lumen per watt, so watts will cancel, and this will be watt per lumen is the unit of this quantity, MELR. And this expresses the amount of melanopic power relative to visible light. So you would compare the amount of melanopic power to amount of visible power. And large MELR means a large amount of energy on the blue side of the spectrum. So it's very basically prone to receiving blue light if you have large MELR. All right, and then the second quantity that I would like to define is CIE S026 Standard, called melanopic daylight efficacy ratio, or MDER. So what this is basically comparing the MELR of the source by MELR of a standard lamp, which CIE chose as D65. So CIE D lamp is a D65 that has color temperature around 6,800. And it turns out that its MELR is 1.326 milliwatts per lumen. I also forgot to mention in the previous slide that you would express this in terms of milliwatts per lumen. So you would you would multiply by a factor of 1,000 to express this quantity in milliwatts per lumen, not watts per lumen. So here you also have the MDER of this source as 1.36 milliwatt per lumen. So that means that if you have the MELER value, you divide it by 1.326 and you get the MDER. It's a ratio. So if you have one, you can calculate the other. And you'll see that we will use this in verification when we are verifying the readings of the lighting passport. So this ratio is quite useful for a lighting designer if they're doing trade-off studies. They want to do, for example, melanopic light and balance it against the color rendering and color temperature that they choose or energy efficiency. It's important to know this parameter, MDER. And finally, you have the melanopic efficacy of daylight illuminance, or MEDI. And that is basically dividing the melanopic irradiance, which we talked about before, by the MELR of the lamp D65. Okay, so if you do that, the numerator is irradiance, so watts per meter square. The denominator is in watts per lumen, and therefore the watts will cancel and you get the unit of this as lumen per meter square, which is lux. Okay, so so this will be the melanopic lux. This is the amount of illuminance, of melanopic illuminance that you would receive. So, and it is because of this weighing function with C lamp. So these are the three important parameters that we need for melanopic measurements as devised by CIE S026. MELR, again, in units of milliwatts per lumen. MDER is a ratio, and MEDI in units of lux. Okay, so we define these three parameters that are quite important. Okay, so next, the question arises at this point that, first of all, how do we measure this? And secondly, what are the recommendations of the CIE or other researchers who work with these standards for what the values should be? So first of all, the way to measure it would be in a sitting position, and you would measure the illuminance on a vertical surface. So it should be at the eye level when you're sitting. So the spectrometer should be horizontal. So it's horizontally measuring the illuminance on a vertical surface. That's the standard way of measuring. And why you want to do that? Because you want to see how much melanopic lux is reaching the IPRGCs, which is at the eye level, at the back of the retina. So there is this paper, which I've mentioned here, recommendations for daytime, evening, nighttime indoor light exposure to best support physiology, sleep, and wakefulness in healthy adults, is by Timothy Brown from University of Manchester, and this is known as the Manchester paper. And they recommend, if you read this paper, they recommend the daytime MEDI of 250 lux, an evening MEDI of 10 lux, and a nighttime MEDI of maximum 1 lux. I mean, the darker, the better, but maximum you want to have 1 lux, which is sometimes a challenge because of all these electronic instruments that we use, and their display could produce more than 1 lux. And if you read the paper also, you'll see there are some examples that are worked out there. For example, in one of the examples, there was a 250 lux MEDI for 500 lux illuminance, which produced 0.5 bright light. condition, and 50 lux MEDI or 80 lux luminance, which had a 0.6 MDER for dim light. And this they claim to have caused alerting effect. So one can use these parameters to do trade-off studies, melanopic blocks, RF, CCT, energy efficiency, and these are very useful. There's also another paper by Serpentier called Fundamental Spectral Boundaries of Circadian Tunability, which talks about basically these trade-off studies. And what are the variations of, say, the melanopic lux when you fix the CCT at a lower value or at a higher value? Very useful paper to read. So I would recommend everyone to read these two papers. They're very, very useful. A lot of useful information. And now we finished with the SI026, and we talk about the other method, the circadian stimulus metric. So this was originated by Mariana Figueroa and Mark Ray from the LRC. I think they have recently moved to Mount Sinai. And in this metric, they define the circadian stimulus. It's basically quantifies melatonin suppression level that are caused by different light sources. And they're then used to determine suitable lighting levels inside the building. So the metric has a level scale from 0.1 to 0.7. So if circadian stimulus is say 0.5, it means within 1 hour of exposure, you would reduce 50% or suppress 50% of melatonin secretion. So at night, you don't want to use a source that has high CS value because you would basically lose the melatonin in your body and you can't fall asleep. They also define the circadian light, which is CLA, is a spectral sensitivity function that characterizes spectral sensitivity of human circadian system. And this is a normalized quantity and it's unitless. So the way it's been defined is that for 1,000 lux of CIE illuminant A, which is just a tungsten lamp at 2,856, its value is 1,000. So one can see from this graph from Mark Ray's paper that CS and melatonin suppression, they're both functions of log 10 of CLA. So this was the original model, and recently in 2021, they modified the model to CLA2. So it was CLA before, and now it is CLA2. So for the CLA model, the 1,000 lux of CIE illuminant A would produce a CLA of 1,000. For CLA2, it produces 813 because of some changes in the model. So here you can see the before and after. This is CLA, this is CLA2, and the CLA2 has a better R-square fit, 0.76 as compared to 0.69. And this is the paper that talks about that. And I don't want to go too much into mathematics. It's quite complicated, but just want to say that this is a two-state system where B and Y are blue and yellow. So depending on what the value of the blue minus Y intensity is, you can say that they would use different formula. In the previous version, if B minus Y was greater than less than 0, this had only this term, 1548. MC lambda is action spectrum for melanopsin, and E lambda is the spectral power distribution. But in this new model, they've added a few terms. So that's why the values are lower, and CS is easily calculated from CLA by using this formula that takes into account the time and also the basically distribution of the light source. So these two metrics, basically, if we want to compare them, we should realize that there are some differences, and they are actually talking about different units. So we talked about MEDI, MLER, MELR, and ME, and the ratios, melanopic ratios. And these are different from CS and CLA. So in fact, the CIE disagrees with some of the methodology of the CS scale. I'm not going to go deep into what the differences are or what the objections are, but what we are doing as a company that makes the meter is to provide both sets of data to our customers. So then they could use both of them. And if they are satisfied with one or the other, then that's their choice. However, in my opinion, the CIE method is more organized, is more well-defined, and is more systematic. So I would encourage you to use the CIE's MEDI and MEDR values. So MDER and MEDI. So these are very important for measurements of circadian light. All right, so now let's look at what we have done here, the beta version 1.80. So what we have done, first of all, the previous version, if you had worked with this before, you had the melanopic, and then we had sort of esconopic. We changed the terminology. We had rhodopic, we had erythropic, or there were some different terminologies here. But now we simplified it: S-cone, M-cone, L-cone. And these were based on past version, which was this. So CNTN003 from CIE. So now we have updated it to S026. So all these values now are different because we are using S026, not this first one, which is CIE TN003. So the first one is MEDI, melanopic lux, and rhodopic lux, and then S-cone, M-cone, L-cone. And we also added this, was not there before, MDER, a point, in this case, 0.462. So this ratio is also added. Okay, next one is we have also updated CLA to CLA 2.0. Okay, so also in the CS scale, you have to do the horizontal measurement in the same way from a vertical plane. So CLA has been now updated to CLA 2, circadian light 2.0, and when this changes, circadian stimulus changes as well, because I showed you in a formula that the both are dependent on each other. So once the first one changes, CS depends on that. It's a function of that. So this is new. And now the question arises as to how do we know that what the lighting passport produces is correct? So you have these measurements of the CLA2 and CS, and also MEDI and MDER. So how do we know if these values are correct? So that's why I want to demo a check on that. Let's double check that. So in order to double check that, we go to this Mount Sinai online calculator. I'll show you how you can use this Mount Sinai online calculator and use the lighting passport data to generate the circadian parameters. So here is that. Okay, and then you would just say add source, and you can name it whatever. Let's say test 1. And here you need both wavelength data and the irradiance data. So I've already downloaded this here. I can download this from the cloud, but I've already put it here. So I'm just going to go ahead and copy both wavelength and irradiance data here on this calculator. Okay, so Control C, and I will go ahead and paste it here. Control V. Okay, and then we say add source. So this source is now added here, and then say continue to calculations. So you can see nothing is appearing here. All the parameters are 0. It's because we haven't specified an illuminance So in order to do that, we go back again to the file. So this was the file that we had, and we will check what the luminance value was. Luminance was 142 lux. Okay, so then we can go back here and put this 142 lux and enter. So once I put this, you can see that this is the measurement I've done in my office. There's a fluorescent lamp with a little bit of sunlight. So this looks normal. And it gave the CS value 0.146, CLA 2106, and MEDI of 65. Okay. So let's remember these numbers: 0.146, 106, and 65. Okay, so this was from the online calculator. All right, and then what about the other parameters like MDR and all those rhodopic lux and all that? Let's see how we can do that. And it actually turns out that the IES TM30 calculator has a CIE S026 alpha OPIC calculator as well. And I'll show you how you can use it. So this was the link. Let's just start the link. Okay, so it just says create table. And here we have to put only the spectral power distribution. So we go ahead and copy the spectral power distribution. So only we don't need the wavelength, has already been generated. Is it possible for us to download? Okay, I'll answer that question later at the very end. So I'll copy this and I'll go here and I would paste it here, Control V, okay? And then you would see you have to click this box, CIE S026 alpha OPIC. So click this box. And then the other thing you need to do is you need to change the units, because the default is milliwatts per meter square, but the lighting passport data is in microwatts per centimeter square. So it's important for you to go and change the units here. And then you can say calculate. Okay, so once you say calculate, you still see the TM30 report, but you can go there and choose the CIE S026 alpha OPIC data. And here you scroll down and you can see the melanopic irradiance. You don't give that, but melanopic EDI MEDI 65, which is similar to what Mount Sinai had calculated. And then it doesn't give you the MDER, it gives you the MELR. So, but we know that MDER and MELR are related to each other. From one of the earlier slides, I showed you that the MDER and MLER are related. You just have to divide MLER by 1.326 to get MDER. So I have done screenshots of the Lighting Passport new app here. So this is from the new app 1.8.0. So it calculated circadian stimulus 0.15 and 0.146 here. So it's a rounding issue here. CLA 106, 106. MEDI 65.6, 65. So these are matches. And then for what we calculated from the S026 alpha OPIC online calculator, all the values. So you have S cone OPIC 47, 46.97, and 116 there, 142 there, and melanopic 65, and here 65. And if you divide the MELR of the S026 by 1.326, 1.32.326, which is the ratio between the two, you get 0.4606, which is the same as what Lighting Passport has measured. So this way, you now have confidence. Getting the PowerPoint would correct. You saw a slide, my light pollution. Okay, so you can see that these are the same. So you have confidence now that Lighting Passport is giving you the correct melanopic and circadian. All circadian values are similar as you put the spectral power distribution in the standard online calculators and do the calculation. So you get exactly the same values, or it is within the rounding error. Okay, so now what is the new version of SGM Plus? It's only a beta version 1.8.0. Okay, and for now it's only for Android, but iOS version will be introduced. You got to give us some time to implement this. For now, what is working is all the values are correct on the app, but they need to work on the data transfer to the cloud. Basically modify the graphs and things like that. And I know somebody asked about, what about Sense? So we are working on that as well. So you should be able, as long as you communicate with the cloud, whether you have Pro or Essence, it should basically work. But this would take probably a few weeks to implement completely. And we would send a mass email to inform all customers about this. So this is the Google Play, the beta version of the app, and I would tell you how you can access this. You can go ahead and play with this if you want. But let me quickly talk about Flickr. So a little bit about Flickr, and then we would go on and how to download the app. So basically, Lighting Passport is able to measure flicker, and there are 3 parameters: flicker percentage, which you can see in this case. The maximum is A here, the minimum is A minus B over A plus B is flicker percentage, and it represents the cycling variation. Lower flicker percentage is better, and over here you have a flicker index, which uses the areas, area 1 divided by area 1 plus area 2, and higher values indicate an increased possibility of noticeable lamp flicker. A lower flicker index is better, and so if you have basically a high flicker index, you could have some kind of stroboscopic effect. So that's increased possibility. Higher values could produce a stroboscopic effects. And then finally, you have the flicker frequency. Lighting Passport is capable of measuring the flicker frequency in the range 5 to 200 hertz. And getting 120 hertz reading is very common because it's twice the 60 hertz frequency of the AC. Okay, so if you ever get a number between 1 to 5, it probably shows that you haven't done the correct measurement. It actually gives you an error message. And the reason is that if you have 1 or 2 hertz flicker frequency, you should be able to actually see that with your eye. So that happens when there is a relative movement between the spectrometer and the light source. So make sure that the light source and spectrometer are not moving with respect to each other when you're doing the flicker measurement, because getting a 1 or 2 hertz flicker measurement is incorrect. You need to repeat the measurements. So this was a quick note about flicker that I added here. Let's go back again to links for the Circadian app. So there are a few useful links here which I will send you. So the first one is for the YouTube. I'll send you right away if you want to watch the first 2 webinars that I did on those 4 lamps. I already talked about that. If you want to look at those, then you can, I'll just enter this here. So this is the YouTube channel. I encourage you to copy this, and we'll also send it to you later. And then for using the beta version, you first need to subscribe to this test version. Join the test program. So I'll send you this link. So join the test program first, and then you can download the beta version. and play with it. And you'll see that it has CLA2, it has MEDI, it has the MDR, all these new parameters, and it also has new metrics or new color vector graphics for TM30. So these are the 3 important links, and if you could copy these, it will be very useful. And basically at the end, I want to thank you for listening to this webinar. We have about 5 minutes where I will actually answer all the questions that I see already in the chat box. We'll send you a feedback form, and if you could please fill this feedback form and let us know how we did and what changes you would like to see, if there are anything that you want to add to this webinar, and we will look at it. So let's look at the questions that are asked here. Let me go back to the top. So Kevin asks, how much of this will be incorporated in Spectrum Genius Essence? So all of this will be in Essence, but at the moment we are only working on Spectrum Genius Mobile Plus. So you have Essence Plus, SGE Plus, it will have all of it, but you need to give us some time to implement it. Dan, also have an Essence, and my old app is SGE Plus. Did SGM replace? No, SGM did not replace this, Dan. SGM is for Standard Pro, but SGE is for Essence Pro. So Standard Pro is typically about 2200 and has more functionality, and Essence Pro is about 1200, so it's a less complex meter. So you haven't replaced anything. James, is it possible for us to download the slides? If so, how can we? We don't provide the slides, unfortunately. We only provide the recording of the webinar. So you will receive the recording of the webinar. So within few days. Dan, getting the PowerPoint would be great. I could use some slides. Maybe you can do screenshots from the webinar recording. As I said, we do not provide unfortunately, we do not provide the slides, just the recording. And when will iOS version will be available? I heard that within probably a week, but we can't be sure because, as I said, they still need to work on transferring the data and then updating the graphics on the cloud. So although the Lighting Passport at 1.8.0 SGM Plus sends the data to the cloud, it doesn't record the new graphics. So they're working on that. It takes a few days. And once this is done for the Android, they will go ahead and do it for the iOS. And we will definitely let you know. Kevin, thank you very much. You're welcome. Great. Thank you. I'm happy. Anyone else has any question? We can still answer a few more questions in the next few minutes. Anyone else has any other question? Okay.
Sorry,
So
will we be able to like see the slides in the record that you will send to us?
yes, absolutely, absolutely. So it's just like what you were watching, you will see the record also. And go ahead and look at what I sent you in this YouTube channel. If you click on the YouTube channel, right? So I'll show you. If I go ahead and you do click on the YouTube channel. So this is the one that I did in April 6th, right? So this is what you will see.
Oh, I see. I see.
So this is some advertisement. Skip ads. I don't know why this is showing this, but okay, here. You can see this is the webinar from April 6th. So you could see all the slides. So you would see something similar for this one as well. And if you need to, show one of these, you could do a screenshot from there. Anyone else has any question? subscribe to the YouTube channel and you will be up to date. Yes, this is our media managers is recommending that all our webinars will be on the channel. All right, so thank you very much again for attending this. It was a pleasure to talk to you about all these changes, and we're excited about these new capabilities of Lighting Passport to measure circadian parameters, and we hope that you could use it effectively to have a healthier light falling on you and have a healthy and happy life. Have a good